to Sunil's before that. So I'm mostly on top of what you've been talking about. It is my first occurrence in this forum though. So if some of the things I mention are a bit off pitch, then sorry, but we'll work that out if and when I attend again in the future. The particular thing that I want to talk about today is I was going to talk about data sharing and what I think is happening in a few cases in Australia, in Australian government. And I'm going to tune what I was going to say with respect to the last couple of talks. I think that makes sense. So Heather, give me a nod if that sounds like, yeah, right, okay, that sounds like the right thing to do, okay. So my involvement in Australian government data sharing started with work in CSIRO in informatics and in technical data sharing, so modeling, those sorts of things, mostly around environmental and agricultural data. At some point, I ended up at Geoscience Australia running their catalogue, ECAT, which is one of the larger data catalogues in Australia. Now, ECAT used to supply about 40% of all the data in data.gov.au, the national catalogue. It's probably a lesser proportion now because there's more stuff there. But I've spent enough time in this data sharing to have some overview of what's happened in data sharing arrangements in Australia at both the technical and non-technical level. And it's that I wanted to sort of go through. So my background is, yeah, I used to work in research, then I operated a national catalogue. Now I work for, I've got two phases of work. One is as a research fellow at ANU, in the School of Computer Science to do with data models. And then the other phase of work is my private sector work for a company which consults on data sharing and data systems, surprise, surprise. And we tend to support government agencies in data sharing things. Some companies as well, not just agencies, but mostly agencies. So thinking back about the things that have occurred in data sharing in Australian government in the almost 20 years that I've been involved. In fact, it is 20 years, 2001. The first wave of initiatives were in this policy space. And I heard, again, Sunil, I only heard half of your talk, but I gather that there's a publication on reflections on issues and things here. Well, I remember back 20 years ago when there was no policy around data sharing. It was the opposite scenario to what we have now. There was a presumption of not, if not secret, certainly undisclosed data. And there was a presumption of restrictive use policies, which are the opposite of open licensing, for instance. So there were several initiatives, and I have to say Queensland, where I'm from, and Australia led internationally in the licensing space, Ausgol initiatives and so on, to actually standardize that. Now, there is a long-term corollary to policies around data sharing, which I'm involved in directly, and that is the actual technical access to sharing information. So a good initiative is to decide on a policy level that you do in fact want to share data. A second thing is that if we are going to share it, under what conditions, and if we can we standardize those conditions to be a list of 10 things to choose from. There's not 4 million things, there's only 10, and we just need to repackage those 10. The longer term thing is, okay, if we have data that is shared according to, some of or these 10 principles in different ways, how can this be automatically navigated? And this is important if we consider a machine internet and situations where a lot of data is shared and a lot of data is automatically accessed and used. Can we be certain that our tools are cognizant of the requirements on data sharing, the obligations in data sharing to meet certain criteria, etc.? So that is an initiative I'm involved in right now, and I'll come back to that at the end of this next little discussion of catalogs and things. But nevertheless, after a discussion on 20 years ago about data sharing, and then policies to share data, and then licensing and initiatives to do with licensing, came a listing phase where government departments started to create catalogs. The agency that I worked for, Geoscience Australia, has had a data catalogue for 30 or 40 years. An electronic data catalogue, that is. It's had a data catalogues for 150 years, but in some form or another, but an electronic data catalogue for 30 years or so. And that catalogue was one of the larger, larger public data catalogues where a good proportion of the data was commonly licensed under Creative Commons, initially 2.5, then 3, now 4. And so there's a lot of data there. If not those licenses, there's a lot of software products from Geoscience Australia that are also conventionally licensed. So that's that listing phase. And then the end, or not the end, but the continuation of that individual agency listing phase was a multi-agency, so government-wide initiatives. And I remember back to when Malcolm Turnbull was Prime Minister, he said something like, you know, data sharing is awesome, go and make cool catalogs. And so they made data.gov.au. Now, a couple of points on that. One is that that is not the end of the story. Putting data in data.gov.au, even if it is fair, you know, findable, accessible, interoperable and reusable, even if it is those things, that's not the end of the story. It is a grab bag catalog. It has a lot of random things in there. There is no planning in the way that that data will be used. And so if you join a data.gov.au hackathon, which I've done several times, and I know some of these data sets very well, I've provisioned 30% of them, even with that knowledge, it's actually very difficult to use data.gov.au and do cool data sharing things. You can get data, but there's a lot of things that are missing. And it's this effective use phase that interests me most. There are institutional arrangements and so on that are relevant to this next bit of discussion, but the thing that interests me most is that, is there data in Australia that is provisioned openly for use, but the usage patterns are known or described? So, for instance, if I'm a geological survey agency and I've got information about, you know, ore bodies, where the gold is, and down the road is an environmental agency and they have information about protected species. And what someone wants to do is to make a map that intersects protected species information with where the gold is, and then work out something to do with, you know, mining leases or whatever. Those data sets need to be provisioned in a way where you can do all you like about open standards and open structures and so on. But if the intended use of those data sets is radically different, they'll be sufficiently different enough that it's very difficult to use them. Now, the opposite end of this is, you know, well, this sort of begs the question, are there actually expected patterns of data use that are generic enough to allow for data to be provisioned for general use, but are actually useful to go and do specific tasks with? And my research over the years is that the answer is yes, there are such patterns. And the patterns usually come down in a couple of different forms. They can be a domain-specific pattern. For this kind of data, spatial data, for instance, regardless of type, there are expected usage patterns of spatial data, namely spatial data intersections, you know, which things are inside or on top of or within or outside of other things. That's one domain. But there are also sneaky patterns which really only computer scientists seem to know about, or metrologists, so people who actually study the science of measurement. Another pattern that is highly relevant is the observations and measurement pattern. So there is a standard called observations and measurement from 10 years ago. And I was involved in some of that, and the researchers I worked with at CSIRO led internationally with that. And what this pattern says is that when you measure things, there's a whole world of metrology that you need to know about, you know, the units of measure, scales, those sorts of things. What dimension is being recorded, length, width, whatever. But there's this separate world, that's the measurement. There's this observation world which relates the act of taking that observation to generating the actual measurement. So when I did it, all those things, who did it, what method was used, all that stuff. And then there's a final domain which talks about how we relate the measurements to the properties of things. So measuring the area of a lake, well, you've got an area dimension, which is a length squared thing that's in your measurement space. The observation is, well, I measured the lake in summer and it's a different area to measuring it in winter. You know, water changes. And then the feature thing is, well, this area is a spatial feature, sorry, a spatial property of a real world feature, in this case, a conceptual lake. And so if we implement common, I guess, modeling patterns here for taking measurements of things, whether they're measurements of financial, you know, how much does this house cost? That's in some sense a measurement. It's a point in time measurement of the market price of a thing, in this case, a house. So whether it's financial or natural world or other kinds of measurements, there is a pattern here where we can associate results with observations, with properties, with features. And that pattern, as far as we can tell, holds everywhere. There are sub-patterns within this, you know, within the spatial community, there's a whole miniature world of spatial measurements and spatial properties. And the research that has now become implemented government systems that I work on says that we can actually formulate data without knowing the specific end use use cases of this data. We can formulate data according to general usage patterns in such a way that it is in fact available for general use and probably also certain kinds of specialized use. So for instance, if we decide that all spatial data needs to consider the theoretical features and the geometries as separate things, that turns traditional GIS systems on their head. They like to think of geometries with properties. If we say, no, there's a theoretical thing, the geometry is in fact one property of that thing. It's the spatial footprint of it, I suppose. That kind of modeling, which separates these concerns a little bit, and again, we can do that spatially, but we can do it in general with observations and measurement, really does lend itself to common styles of querying. Now, to make sure that this is in fact real and really happening, the current data sets that I'm working on at the moment are spatial data from a number of agencies, administrative boundaries, natural resource things, flood zones, infrastructure like power lines, so a lot of spatial stuff from the Bureau of Meteorology, from Geoscience Australia and CSIRO, and population data from the Bureau of Statistics. And the population data, until recently, has been presented as second-class citizens or annotations against spatial data. And you would use one system to do the spatial, whatever it is you want to do, subsetting the data to a state or whatever, and then a very different system, a statistical package or some code to fiddle around with the numbers. Now I've got the spatial data, sorry, the population data just for New South Wales, and now what I want to do is to just, you know, cut out, you know, include only people over 75, whatever it is. But in fact, if we implement these observations, measurements, patterns, the spatiality and the populationness and counts are really all just properties of things, features, aggregations of features, and so on. So this higher order conceptual modeling, in my mind, is absolutely required for the next phase of data sharing. We actually can't just keep throwing things into catalogs and imagining that they will somehow be able to be used. They do have to be aligned in certain ways. Now, one of the questions we might ask is, well, is there a universal set of models that we can probably come up with, or in fact, are there many potentially different ways of doing these things? And it's sort of a bit of both, in that there are definitely some higher order models that make a lot of sense for a lot of people. That observations and measurement one is one of them. Spatial modeling of a certain sort is another. Human-centered modeling, you know, properties of people. People are obvious real world things with properties that different agencies and everyone care about, and we can do things there. So yes, there are some. There are also many submodels that could fit within there, and we certainly don't want to be creating data that's for sharing that is fixed on one of these potential submodels and excluding the others. And there's a whole set of model mechanics around applicable models, choosing which ones are relevant and allowing models to coexist. That's the kind of world of the semantic web stuff that I work in, and we very explicitly model data, and we model the models, and we provide access to different model views of chunks of data. So you might have a spatial data set which is spatial first in some ways of viewing it, and in other ways is actually not spatial first. You know, maybe it's the total numbers or aggregates or the observed properties or who knows what. Same data, but just viewed in a different way. And that is not to say the formats are particular formats. This is independent of formats. These are the information model views of those chunks of data. And in fact, I am an author of an international standard around internet negotiation for data according to, as it's called, profiles. So what information model view of this chunk of data do you actually want? That's an internet standard. Okay, so I believe that this kind of conceptual higher order modeling is necessary. How does this get implemented, and what do governments actually do? Well, government doesn't really have one agenda. They have communities with agendas and sub-agendas and so on. So the thing that seems to be happening at the moment is that a particular community will come together with a strategy and implement data sharing and data models and so on for their domain. So there are certain spatial units of government that do this. There's also the mining community that I'm working with now. There's the environmental community. There's the health sectors and so on. We do want higher order models in place above these communities, but it's really specific communities that end up implementing particular things, like 10 different data sets from the States and federally and New Zealand all coming together for some particular set of purposes. If we can have these background models in place, then as communities come on board, they can implement data according to their particular community's models, but with an eye to these higher order generalized models, which will allow for integration, which they haven't even necessarily predicted. So if, for instance, they're using observations and measurement patterns, it may be that their mineral data links to fisheries data in the future. So that's the kind of consulting that we're doing. It is semantic web driven. There was a vision 20 years ago to make a magical machine readable internet. We see parts of that having been implemented. We don't have a magical world user that wishes to see everything used everywhere, but we do have, as I say, specific communities and increasingly more and more cross-domain communities that want to integrate data. And my long-term vision is that there is some sort of, if not worldwide, Australian-style government grand plan in general to use certain higher order models, pick some winners, you have to, but also cater for a range of models and actually state what these assumptions are as data is provided, which models they align with, such that hackers and hackathons and so on can come along and actually leverage that. Without those upwards alignments, it's very difficult. The Linked Data Working Group, the Australian Government Linked Data Working Group, is a technical advisory group that provides information to government on this basis. It deals with linked data, semantic web technologies, and so on. And I can announce that the Linked Data Working Group will announce tomorrow that the Department of Finance, for instance, is providing a semantic web view of structures of Australian federal government. This is the results of research that I was involved with many years ago. And it's one of these data integration spines that are becoming available. Spatial data is one, human-centered data is another, government structures another. These are the reference data sets according to these higher order models against which other individual shared data elements should be linked, I suppose. So the Linked Data Working Group does that sort of technical advice. And as a researcher, then I bring theories and so on from semantic web to bear on that. So that's my link to this group through Heather and the Linked Data Working Group. And it sounds very technical, but it's usually not technical. It's usually, do organizations with data, once they've gone beyond the licensing and the listing and so on, do they understand and are they interested in higher order concerns to facilitate data sharing and data integration? I think is that my time?
That is your time, Nick. Thank you very much. Very fascinating, and right, we've had three very different kind of views on open data, all equally interesting. Heather, would you care to make some comments?
Thank you so much. I was really excited to, instead of talking too much about my own work, to try and bring together these perspectives, because I knew that we had two social scientists and one computer scientist, and often it feels like we speak different languages. So I thought I would talk a little bit about, well, I'd find some ways of trying to bring these perspectives together, because I think they're all really valuable and show different facets of this problem. So we talk the problem that we talked about and we started with, which is open data and sharing, and what it means in practice. Just a few sentences about my own work. I started as an activist in the free and open source software and open content movement in the early 2000s, first in South Africa, then in the UK, and then in Silicon Valley and in Kenya. And I guess my work is really about the internet as a global project. So thinking about how it's served some of its promise as this kind of great equalizing force, but how it's disappointed in others. And working as a free and open source software and open content activist in those early stages of the 2000s, and especially in South Africa and other developing countries, what I really learned was that openness, as it was materialized, I guess, in terms of copyright licenses, essentially, was really valuable, right? I mean, it's still incredibly valuable and essential for public knowledge. It does enable access. It does enable innovation. It's really essential if we are to develop any global solutions to things like climate change. But essentially, it's limited, and it's limited by its history, its origins, its technical makeup. But that's not, that's not a terrible problem. I think what we need is really to think about new kinds of vocabularies to understand its limitations and to make up for those limitations when we're trying to implement open data projects in global contexts. So now my work, my work in the early 2000s as an activist was really about free and open source software. And now it's moved to thinking as a researcher, mostly, about the semantic web. So it's actually nice how the talks moved from talking about open data to then talking about the promise of the semantic web. And that's kind of where we are at now, where we've moved through this moment of kind of HTML, then talking about a web of documents, I guess, and then talking about data, and now talking about data models. And what's interesting as a social scientist is to see similar types of promise around the semantic web as there was around free and open source software and open licenses. And so it was really interesting then to hear, so working in South Africa, it became really clear that, putting a license onto something, as Nick said, is not the end in itself, and as Sunil said, we came into this thinking that an open license would equal transparency. It just would necessarily result in this stuff. It would result in people sharing, innovating together. But, and it would also result in the removal of intermediaries, right? I mean, I worked for Creative Commons for many years, and one of the big rallying cries was that we were going to remove intermediaries, and that was the lawyer then. But what we've actually seen is the rise of new intermediaries, right? Maybe not lawyers predominantly, but definitely a new class of intermediaries. So it's not had the same kinds of effects that we imagined it would be. And that's not all bad. There's been some really great innovation and access that's happened because of it. But what was really interesting was to hear, starting with Sunil, about this question of what does open data need in order for it to work well, right? And Sunil's answer seemed to be that it needs to be more expansive in terms of understandings of openness. And I can definitely relate to that. Our conceptualization of openness is very, very specific. I mean, openness, as we've come to determine it, is very, very specific, and doesn't necessarily immediately result in all those things that we expect it to. So, more expansiveness seems like a really good idea in terms of making it work. If it's going to work, it needs to be like a boundary object. If Susan Lee Starr's work needs to be able to translate to many different types of organizations, institutions, and groups. And then Svetlana, on the same question, in order for open data to work, what does it need? Her really fascinating talk about these really great case studies, and those diagrams are just fascinating. Like, they really expose the kind of institutional networks that are part of that really are foundational and behind this, you know, the press release about going open, the answer seemed to be that in order for openness to work, it needs to adopt this innovative approach, which to the researchers in the project was about sharing not as an end in itself, but about the process of deliberation, right? So it was open-ended, and it was about working out what it meant to the people involved in that project, or and even with end users as well. So that was, yeah, really interesting way to start thinking about how does open data, how could open data work. And then Nick, the computer scientist, takes another approach because he's obviously been involved in data sharing for a long time in the Australian government and has seen a lot, and also comes to the same conclusion about the fact that we do need kind of standardized conditions of access. So licenses, for example, we need to be using similar types of licenses, otherwise it doesn't really enable the kind of sharing that we imagined. But he talks about something that I really can empathize with, which is about this idea, you know, sharing was, it used to be about, or it is still in many cases, about imagining, you know, the world. So just putting the stuff out there and expecting the world to come to it. And, you know, not really having particular types of end users in mind. And I think that came through in Sunil's talk as well, that it's really important actually to think about end users. And Nick's talk, and, you know, he's an expert in this, is about the next phase of the web, you know, the semantic web. And in order for data sharing to be useful, it needs to, data needs to be reusable, and it needs to be reusable, and it can be reusable using these kind of expansive universal models for data. And so that's, you know, a really exciting new technological stage for the web. But I guess as social scientists, we'd be really curious, and this is my work, right, is to try and understand, on top of the technological solutions, what are the, you know, like what are the interesting social conditions or social relationships that develop around these new technological ideas for the sharing of data. So inevitably, it will mean that we'll see lots of innovation, but we'll also see some weaknesses and challenges, and it's about trying to figure out how to connect those dots and really try and mitigate against those challenges. Because ultimately, I think this is really about, well, for me, I think, and for many involved in the web, and I'm sure everyone who's talked today, it really is about, you know, equalizing and collaboration on a global scale. And that's the only way that we really will solve the greatest global challenges, is about enabling that. And you know, true openness, which is about being open as people to others. And that's really crucial, but it requires, you know, lots of different machinery in lots of different contexts.
Okay, thank you, Heather. So we've got some questions, I think. So there was a question from Samara, who was interested in Svetlana's findings about dynamic versus fixed governance structures and frameworks for data sharing. So do you see governance as a type of infrastructure? Comments from our speakers.
Svetlana, you first, please.
Thanks for this idea, because actually we hadn't thought about governance as infrastructure for this particular case, but it totally makes sense in so many levels. And first of all, because of the way you can think about these organizational structures as enabling the flows of data, and second, because of the way you can think of infrastructure as a way to enable the penetration of power and control through different organizational structures, as Michael Mann writes about the infrastructural power of the state. And also in one very interesting way, that often infrastructures tend to infrastructures tend to endure in a very interesting way, because sometimes they are repurposed, and in new technological or social situations, an old infrastructure can serve as the basis of a new one. And this is something that happens in this in some of these partnerships. For instance, in Social Science 1, this is what happens. Actually, the ethics review board of the university is repurposed data sharing governance goals of Facebook. So thank you for the idea. I will definitely steal it.
Thank you. Nick, I think you were about to say something.
Yeah, I wanted to mention a project that I was involved with that had an interesting combination of data and governance structures. So a few years ago, there was an initiative at the federal government level to do a bit more with cumulative impacts of coal seam gas mining. So they invented this project called the Bioregional Assessments Project, and the project assembled a bunch of data sets to create a data baseline for organizations to assess impacts of, I'm going to go and build another mine, not just the direct impact of that mine on the nature, but the cumulative impact of multiple mines over time, that sort of thing. And this had a lot of scientific data, where the water goes and where the coal is and where the animals live, but also had a lot of other data, administrative things, native title claims, all kinds of stuff. So it was a very large data project, and the data was, some of it was heavily encumbered. A lot of the data came from mining companies, a lot of it came from state governments, Aboriginal groups, etc. So there was this very crazy combination of data access, permissionings, and so on going on. And the governance, there was a committee made to create and release data, that sort of thing. But when they started the project, the extent of the complexity was not known. And so the structures that they came up with initially weren't really sufficient to cater for what they were doing. They didn't have the nuances in the permissions and so on to do things, even if the committee could decide to release this and that. Now, I did put in the chat before a link to, in fact, something that was involved in that project, which was the actual modeling of requirements to do things or not do things with data. Now, there are more recent initiatives in this space, but there are now models which can talk about individual requirements or prohibitions, obligations on data use in general, and then you can look at a scenario, and if it's, maybe there's only 2 requirements, you've got to, attribute the source or something, but maybe they're very difficult ones, like you have to anonymize data, etc. So do you have the requirements modeling skill to actually model these things? And if you do, if you can actually model them, then can you implement a governance structure that can handle them? And what things can we do that help with governance? Well, one of the things you can do is try and automate some of this stuff. If you have notes on requirements, you can look at downstream data sets and data dependency and things, and actually calculate, well, we can't automatically release this data set because its parent data set or one of its ancestors encumbers it in some way. And the particular contribution I made was to say, well, we can even go beyond that and say, if we can annotate data in a certain way that makes a claim that a requirement has been met, maybe the requirement is to remove humans' names from a data set or whatever it is. If we can actually measure that and indicate that, we can then annotate the data provenance chains with that information. This requirement has been satisfied, and now the downstream data sets are unencumbered. And when you've got heaps of requirements, the more automation you can do, the better. So the Bioregional Assessments project had 3,500 data sets. They started with 60 licenses, and on reflection and a bit of modeling, that ended up with 7 licenses with 8 different conditions, and the ability to automatically handle 2 or 3 of those 7 or 8 requirements. So attributions and so on. When a data set is presented, the attribution statement is made available, etc. So they couldn't do lots, but they could do some. And this reduced the governance effort. The governance committees could be comfortable that certain catalog processes and so on catered for some of the things that needed to be done. And then they could focus on the other things that weren't able to be automatically handled. But this is a nice example of a combination of the technical and the governance really integrating pretty tightly. The more modeling skill you've got, the more automated things can be, and the less human effort you have to go to govern semi-governable situations.
Thank you. Any more questions? So I think Svetlana has actually a question for Nick. Am I understanding correctly that you were trying to automate the processes of categorizing and access to data sets?
Well, not really categorizing. Well, yes. I mean, what we actually established was a provenance chain of what you might think of as source data right through to products or aggregates and so on. And that's a normal provenance exercise. But then what we did was we said that some form of access control of the products and intermediates and so on is actually dependent on elements within the provenance chaining. So you look at a product and you realize that its ancestors are encumbered. Are there annotations in the system to say that some of those encumbrances have been either dealt with or lifted and so on? And if not, you can't release it. One of the things that was somewhat unresolved was just attribution statements. If I've got a data set that requires attribution and it's got ancestors that require attribution, how do I, as a downstream user, do that attribution? Do I compound those statements? And there were some crazy things set up initially in the project. We would literally take, you know, copyright of agency X, Y, mining company Z, whatever, ram them all together, and the product would say, this product is copyright of blah. Now that's simplistic and not perfect, but it's a start. It's a start to say there are real world processing chain links between things. Let's call them provenance statements. And some of the interesting things to know about provenance are not just the methods used, not just the volumes of data, but attributions, licenses, requirements, encumbrances at that human level. We can annotate them and we can start calculating stuff. Right statements are not that difficult, but certainly costing releases, all those kinds of things. You know, what about proportionate cost? If there's a costed data set and an uncosted one, what does the downstream thing look like? And you can actually start to deal with that once you've modeled these things. So magical modeling solves every problem really, but no, that's provenance change was the core modeling that I did, but it incorporated licensing, access control, etc., attribution.
Okay, thank you. I think we're at time now. Any final comments from our speakers?
I just wanted to thank Nick again. He is our guest in some ways. Thank you for coming along. And Matt, thank you again for hosting and for inviting us all along.
No worries. So thank you very much to all our presenters, and thank you very much to all of our participants as well. We really appreciate you taking the time to come here tonight. Thank you.
Thanks.
Thank you.
Thanks for
having us.
organizing.